everybody, this is Algebra 2, Lesson 31, and this lesson is about negative reciprocals, perpendicular lines, and remote interior angles. So we know that the reciprocal of a number is when you flip your fraction upside down. So if you have 1/3, you flip it upside down, and the reciprocal is 3 over 1, which is really 3. The negative reciprocal would just mean to make that negative. So if we have the number 4, we flip that into a fraction, so 4 is really 4 over 1, so we get 1/4. And to make it a negative reciprocal, we just make it negative. So negative 1/4 is the negative reciprocal of 4. Okay, super easy. So to get the equation for a line that is perpendicular to another line, you use a negative reciprocal of that line. So we know that in the formula y equals mx plus b, our slope is m. If we want a line, let's say that it's going like this, and we want a line that's perpendicular to that, that means it crosses it with a right corner, a 90-degree angle on the corner, then we're going to flip that m value. Let's say that your slope is 3. We're going to take the negative reciprocal of that, so that would be negative 1/3, and that would be the new slope to our new line. Okay, so one line's going up, it's a positive, the other line's going down. Okay, so we have to make it the negative reciprocal. All right, so the problems are going to look like 31.1, and I'm on page 142. And this one says, write an equation of the line that is perpendicular to y equals 2 over 5x minus 3. And it passes through the point 3, 2. Okay? So it gives us a point, and then it gives us the line that's perpendicular to the one that we have to find. This point is going to be on the other line. So let's say there's one line, and I could graph that line to show you guys what it would look like. So the line y equals 2 over 5x minus 3. To graph that, we're going to go to negative 3, and that's our y-intercept. Remember, this last one's the y-intercept. And there's our slope is 2 over 5, and that's rise over run, so we go up 2 over 5. 1, 2, 3. So right there, up 2 over 5, like that. And then I can take my ruler and draw that line. Okay, so there is that line. I'm trying to find a line that's perpendicular to that, but if I just flip that fraction, it could cross anywhere. We don't know. If I just flip that slope and make it the negative reciprocal of that, which would be negative 5 over 2 instead of this slope, that's going to be a line perpendicular to that. It also had to give us the point that crosses through. Okay, that point would be 3, 2, so I'll go up 3 over 2, and then we could say the negative reciprocal of that, negative 5 over 2, so we would go down 5 over 2, so 1, 2, 3, 4, 5 over 1, 2, right there. And then if we drew that, we would end up with this perpendicular line. So there's our two lines crossing each other. They're perpendicular. That's a nice right angle right there. But we have to find out what the formula or the equation for this line is, and you can do it without graphing it out. That just kind of shows you this one slope is 2 over 5, and then this one slope is the negative 5 over 2. Okay? All right, so how do we solve this problem? We've got y equals 2/5 x minus 3, and we need a line perpendicular to that passes through this point. Well, we know that we've got y equals mx plus b, and our m is going to be the negative reciprocal to the slope that we already have, so we're going to say negative 5 over 2. That's going to be our m. And then we've got an x value and a y value right here in this point. So the 3 is our x value, and the 2 is our y value. So now the only value we have to find is b right here. So we just set up the equation. So y is 2 equals, our m is going to be 5 over 2. Our x is going to be 3. And that is going to be plus b. Okay, so I just said y equals mx plus b. Now I just have to work it out and solve for b. So that would be 2 equals 3 times 15 over 2 plus b. And then we have to go minus 15 over 2 on both sides. And this 2 right here, we can change that into halves. That would be, let's see, 2 halves would be 4 over 2. Oh, it has to be negative 5 over 2. Whoopsie. So that would be negative, and this would be negative. So we're adding that. There we go. So those cancel, and we get 19 over 2 equals b. Okay, so now we know our b value, and we can write our equation for our line, which is y equals, here's our negative 5 over 2, that's our m, and then x plus b, which is 19 over 2. So that's your answer right there. Okay, that's how you do that kind of problem. That's 13.1. All right, the rest of this lesson goes over remote interior angles. All right, so a polygon has one interior angle at each vertex. So here we've got a polygon. Say we've got a triangle like that, and it's labeled as A, B, and C. All right, and then we've also got these lines can extend. So let's say that that's E. And we know that this one across from it would be the same as E. And we know that this one would be C because they're opposite angles. All right. So the remote interior angles, so let's say that we're trying to find C. These would be the remote interior angles. So they're interior because they're inside the triangle, and the remote because they're not touching the angle that we're trying to find. So let's say that we're trying to find E right here. This one wouldn't be remote because it's touching. These two would be remote. Okay, so it says that we want to prove that the measure of an exterior angle of a triangle equals the sum of the measures of the remote interior angles. That means that this angle, E right here, is equal to the remote interior angles. So that means E would be equal to B plus A. And we want to try to prove that. So if we said A plus B plus C equals 180, right? Because all the angles in the triangle equal 180. And then we see that this is a straight line right here, so we know that C plus E equals 180. And we know that we have a postulate that says that if two things are equal to the same thing, then they're equal to each other. So that means that this would have to be equal to this. So A plus B plus C has to be equal to C plus E. Now we can just subtract this C off of here, off of both sides, and we get A plus B equals E. And that shows us that these two remote angles are going to be equal to whatever the measure of E is. Okay, so this one is going to equal those two, and there's the proof for it. All right, so pause the video and do the practice problem, and then I will come back and work for you. Okay, hopefully you pause that, and this is going to be practice, and there's only one practice problem. And it says, write an equation of a line that is perpendicular to y equals 1/4 x minus 2, and it passes through the point 1, 2. Okay, so we're going to say y equals mx plus b, and then we're going to try to figure out some of these values. M is our slope, and that's this right here, and we need the negative reciprocal of that. So m is going to be equal to negative reciprocal of 1/4 would be negative 4. And then we have a value for x and y that we can get from this point right here. X is going to be 1, and y is going to be 2. Now we're just going to fill those values in here and solve for b. So y is 2, m is negative 4, x is 2, no, x is 1, whoopsie, plus b. Well, negative 4 times 1 would just be negative 4, so we got 2 equals negative 4 plus b. Now I got to get rid of this negative 4, so we add 4. And we get 6 equals b. Now we know our b value and we can write our equation, which would be y equals m, which is negative 4x plus b, which is 6. Now if we wanted to prove that, we could graph those lines. So I'll start with y equals 1/4 x minus 2. So I'll go to negative 2, and I go up 1 over 4, up 1 over 1, 2, 3, 4, like that. And then I could draw a line for those. Okay, there's that one. And that one is y equals 1/4 x minus 2. Okay, and then my new equation is y equals negative 4x plus 6. Alright, so we're going to go up 6. 1, 2, 3, 4, 5, 6, right there. And then we're going to do negative 4 as our slope. So down 4, that really means negative 4 over 1. So our rise is 4, down 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And then I'm going to draw this one. And we'll see if it looks like it's perpendicular. Yep, so we've got two perpendicular lines there. Alright, that is it for lesson 31.